start the next session that will be presented by Antonio López Alcaide. It's the, let me check. It's a responsible of the business in Spain from Agroop, a company based in Portugal. And his talk is entitled Crop Monitoring for Better Water Management in Agriculture 4.0. So as you want to start, it's almost a minute to be on time, but I think that we can continue with the presentation. So Antonio, thanks for accepting our invitation, and the floor is yours.
Okay, well, thank you very much to you, Albert. Can you hear me well? Can you see me well?
Perfectly.
I would like to thank you all and say thank you for inviting us, for having us here, for giving us this opportunity, okay, to be known and to explain what we do and who we are. So basically, like you said, I am Antonio López. I am a business developer of a group in Spain, okay, and I am going to be the person in charge of this speech, of present you a group, okay. So basically, the objective of this speech is going to be, I want you to understand who we are, okay, what we do, and how we work, okay. I want it to be like very practical. So I'm going to divide this speech in 3 parts. The first part is going to be an introduction, okay. I'd like to share you a video. In this video, you will see Bruno Fonseca. He's the CIO of Agroop, and he explains really well who we are, okay? In the second part, I'm going to share with you a presentation. I'm going to do a presentation. I'm going to go a bit deeper in our work, in what we do, Agroop do, to help farmers. And in the third part, I'm going to share with you, I'm going to present you FARMOO. FARMOO is our platform that we use to help farmers to reach their targets and to save water. That's the reason, because I decided the title of my speech to be Crop Monitoring for Better Water Management in Agriculture 4.0, because that's what we do, crop monitoring, okay? So let me share with you this video so you will have a better idea about who we are.
Facing one of its biggest challenges in its history. The world population is growing, and it's predicted that in 2050, the total number of inhabitants in our planet will reach the stunning 9 billion mark. According to FAO, this will represent an increase in food requirements of about 60% in the next 3 decades.
Companies like Agroop will be crucial to help farmers to keep up this demand. Let's make sure that the farming sector will be able to increase production in a more efficient way while using less natural resources. In our first case study, we have shown that our technology can reduce water and energy consumption by at least 30% while increasing the yield's quality. But this is just the beginning. Currently, we are working with a multinational crop nutrition company to help them understand the effectiveness of their biostimulants products on crops through Agroop's monitoring technology. The possibilities are practically endless.
Agroop was the first Portuguese startup that successfully completed not only 1, but 3 crowdfunding campaigns on seeders, reaching 257% overfunding in the last one. With the investment raised, its team has developed a new combined and very scalable product based on Agroop cooperation, an operational management app, and an easy-to-use IoT device called Stoop. The Stoop measures crop data such as air moisture and temperature, soil moisture and temperature, as well as solar radiation, and then sends it to the app. This way, our users can understand their crop's water needs, know when the plants are at risk of developing plagues, diseases, or fungi, create field records, and receive operational recommendations from the agronomists who support them.
We have fully launched our combined product in January 2008. At this point, customers in 8 countries and 3 different continents: Europe, America, and Australia. Now that we have validated our business model, the initial value propositions, product traction, and its scalability potential, we are looking for investment to move the needle, support our continued development process and scale-up plan, moving into markets like California and Australia, where we already have early adopters, customers, and partners. I know that we have the right team to materialize our roadmap, not just because it's made up by committed people, but because I know that each and every one of them is prepared to fail fast and learn quickly.
In 2016, Monsanto bought an AgTech startup called Planet Corporation for $1 billion. Not just because they saw the boost that these new technologies can bring to the farming sector, but also because they know that feeding the world is one of the few things we cannot afford to neglect.
Imagine what you can do after reaching thousands or millions of data points and the worldwide customer base. Imagine what you can do using big data, machine learning, and AI to provide value-added insights that couldn't be generated in a conventional way. It's been an honor and a privilege to be able to follow my dream and to dedicate my life and my passion to this ambitious cause. Hope you can join us on this mission. Let's ensure that in 30 years from now, we will have healthy crops growing in our fields and tasty food on our tables. Thank you and see you soon.
Okay, so I think it's very easy to understand who we are. And now I would like to share with you a presentation, okay, of a group for you to understand better what we do. Like Bruno said, and like you could see in this video, we are an AgTech company, okay? We are from Portugal and we work in precision agriculture, okay? So what's what we do? Crop monitoring. I'm gonna show you more or less who trusting us. Like he said, like Bruno said, we are a Portuguese company. We started in Portugal, but we work not just in Portugal, but also in different countries, so many different countries, such as Spain, and not just in 3 continents, but in 4 this year. So we are happy to say that we are also working in Africa. At the moment, between Portugal and Spain, we have more than 400 sensors implemented, installed in the field. Not just 300, but 400 sensors. And we are working with so many different customers and companies, not just big companies, but also small farmers. What do I mean? What I am trying to say is like, we are happy to say that we have democratized this technology. We have made it accessible to anybody and to any farmer. So basically, what are our main challenges? What is our philosophy? We try to help farmers to do a better water management. Basically, what we want is a more sustainable agriculture in the future. So that's the reason because of we are here. That's the reason because this project started in 2014. And that's the main reason because of we want to help farmers, okay, to help them to save some money, save resources, but also to help the planet. How do we do this? How do we help farmers? With FARMOO. FARMOO is our platform, okay? This platform is available for smartphones and PCs. And basically we use big data, artificial intelligence and machine learning to help farmers through FARMOO, okay? So what do the farmers get in FARMOO? What information are the farmers getting from FARMOO? Well, they get information from 4 different sources. The first one is satellite imagery, okay? This satellite imagery, we work with Sentinel-2, and we provide these pictures to the farmers, and not just to farmers, but also agronomists. And we work with the NDVI index, okay? This is an index which is normalized difference vegetation index And basically, what it allows to the farmer and to agronomists is to control and to monitor the development of their crops. Okay, they can control and monitor their crops and know the vigor, how vigorous their plants are. Okay, so this is really helpful indeed, indeed for them. The second source of information are our sensors that we install in the field. Okay, so what parameters do these sensors measure? For example, soil moisture, soil humidity, soil temperature, air to humidity and temperature, solar radiation, rainfalls, wind speed, etc. And they all are connected by EOT, okay, the Internet of Things. The third sort of information is weather forecast. Okay, this is really helpful and indeed really useful because all farmers use this sort of information a lot. And the fourth source of information are field records. I mean, observations that agronomists and farmers can see in the field, in the crops. Okay, so basically, all this information in FARMOO, okay, we cross data, and that data is really useful for farmers. So basically, how do we work? How do we do this? How do we install these devices? Okay, first of all, we need to decide the amount of sensors, of devices that all farmers are going to need, and not just the amount of sensors, but also the location of the sensors. So how do we do this? We use satellite, we do a satellite diagnosis. Basically, we identify homogeneous areas, okay? We use the satellite, we use the NDVI index, and we identify the best areas where we can install, where we should install these sensors. But not only satellite diagnosis. I mean, we speak to the farmers, and this is indeed one of the main questions, the most common questions that farmer asked me, which is like, how many sensors do I need before anything else? It's like, well, I'm not going to tell you that. Your crops and you are going to tell me that indeed. So basically, it will depend on the evolution, on the development of the crop, but not only that, but also the crop. For example, depending on the amount of different crops that the farmers have, we will need 1, 2, or 3 sensors. If the farmers have 2 different crops, olive trees and almond trees, obviously they will need 2 sensors. One sensor is not going to be useful to measure 2 different crops. Not only that, but also the variety of the crop. Imagine olive trees, Arbosana and Arbequina are not the same variety, or Picual. We need 1 sensor for each variety because each variety works differently, and the evapotranspiration of each variety is different as well. So basically, that is another factor that we need to bear in mind. Something else that we need to ask to the farmer is, okay, how is the soil? Is it the same soil everywhere in all your crops, in all your lands? If it's not the same soil, we will need to have more than 1 sensor. It's not the same sand than clay, so we need to differentiate very well. And I could keep telling you factors, I mean, orography, etc. So first of all, like I said, we need to decide how many sensors and where. The second step is the installation, the deployment of these sensors, okay? So it is really simple. The sensor is really easy to, you will see it later. It's really easy to implement, to install, and it's not difficult for the farmers to do it. First of all, we do it first time, and then we teach them how to do it if they want to change it, because this is something good from all sensors. It's really easy to use them in one land, and then take it and go to another place and use it in another place. The third step is the training. We teach farmers and agronomists how to manage our platform, and how to understand all the graphs that they're going to have. Something else that we do is water management reports. In the case that they need help, farmers need help, etc. Well, we help them with some reports about water management or edapoclimatic reports. let's talk about numbers. So what is the expected result and impact from this technology? Well, in all studios, all cases of studio, like you could hear before and you could see before in the video, we actually know that our technology is helping farmers and agronomists to save approximately 32% of water, 32% of energy. They have an increase of production of around 12.6%, and also they have more homogeneous production, which is really helpful. This is approximately, like I said before. I have some customers which, and this is real, they complain because now they are actually spending more water than they used to in the past. And that's very obvious. In the past, they were not applying enough water. So this is also helpful for that. It's not just to save water, but to know if the water that you are applying is enough and is also in the depth that we need and that they need. So basically, how are we different? What is our differentiation from another companies? Well, we centralize 4 sources of information in just one platform. Most of the competitors provide 1 source of information, 2 maybe, not 4. So when we cross all this data from these 4 different sources of information, the information that the farmer gets is really useful. And it's very easy to understand, not just useful, but easy. The future is complete. What do we mean with this? We are a very dynamic company. We are, I'm not going to say a young company, but very dynamic. All our team is very dynamic, and we don't stop innovating. So at the moment, we are focused on water management, but in the future, we want also to help with fertigation and prevention of risks. Indeed, you heard before, probably in the video, about Coop. Coop was the last or old platform. The current one, the new one is FARMOO. In the old one, we had prevention risks. In the new one, we don't have prevention risks now because we have another utilities, another useful things, but we are going to implement it. All this together is really useful. So let's talk now about numbers. Not numbers, but money, okay? How much do this technology cost to the farmer? There you have. At the moment, I'm going to show you the basic package, okay? The basic package and how much money it could cost to any farmer. At the moment, the basic package costs 1,775 euros plus taxes, okay? What is included in this package? Well, the Stuck is the sensor, okay, that we installing in the field. 1 Stuck, the training, okay, and the EIOT, a fee that we pay, and the software fee. Basically, this is the first investment that the farmer needs to do, but this is not every year. So what is the cost of maintaining this technology? Basically, 375. The second year, the farmer has to pay just 300 euros from software fee to access to the platform to FARMOO, and the EOT fee, which is 75 euros per device. Okay, if they have got 1 device, it's 75 euros. If they have got 2, it's 150. Okay. So really, the cost of maintaining this technology is not expensive. And also, maybe some of you think, well, I think it's a bit expensive. I don't think it's something cheap. Let me give you an example, okay, tell you an example about one of our customers. This man, he owns 40 hectares of olive trees in Spain, here in the south of Spain. And 2 years ago, he was paying the amount of 8,000 euros in water. That's what he was spending in water, okay? The following year, when we met him and we were talking about if he was happy, we were asking me, are you happy? Okay. And he was telling us, well, this year, in comparison with last year, I saved around 2,500 euros in water, but also he increased his production in around 5,000 euros. He had 20,000 more kilos of olives, which translated to euros is around 5,000 euros more. So basically, he was saving 7,500 euros in just 1 year. And he paid around 2,000 euros for this technology. What does it mean? He got his money back in around 4 months. So yeah, maybe 2,000 euros doesn't seem cheap, but trust me, it is cheap. Once you have, you have the return of that investment back, and you realize that it's so fast. It's not even 1 year. Before 1 year, you have your money back. So I'm going to show you now some of our sensors, okay? The Stuck is the one that I was talking about. This is the most common one that we use, okay? This is very simple. And what parameters does Stuck measures? Solar radiation, air humidity and temperature of the air, well, obviously of the air, and soil humidity and temperature at different depths. So this is like a little weather station, okay? It is, as you can see, really easy to maintain, no cables, easy to deploy, autonomous. I mean, so simple. Another one is Plovo. Plovo is a pluviometer, okay? And it measures rainfall, air temperature, and air humidity. And Aero is an anemometer. What does it measure? Wind speed, solar radiation, air temperature, and air humidity, okay? Aero and Plovo are they both together are weather station really. So it is really useful if the client needs a weather station. So like I said before, some of our reference customers, there you have them, are big companies, but we are so proud to say that not just big companies, also small farmers, okay? I really want to put emphasis on that. This technology is accessible to everybody and to everyone, okay? Now, to continue, the presentation of Agroop is done. I hope you could know more or less who we are. And to continue, I'm going to present you FARMOO, okay? So you can see a real case of a farmer in FARMOO, okay? So you will see basically the information that they achieve and they can get in FARMOO, okay? So there is FARMOO, okay? This is one of our clients, okay? And you can see the first thing you see is the farm, okay? The land from the air. This is a satellite image picture. And like I said before, in FARMOO, we have 4 sources of information. The first one is a satellite image, okay? And if you see, look at this. So I'm gonna look at how simple it is to control the development of the crop. So basically, what you can see is the land, is the crop, is the field, but with the NDVI filter, okay, the NDVI index applied in this farm. So basically, the farmers have to identify 3 colors. It is so easy to understand. 3 colors. Green means the vegetation, the crop is vigorous, okay? The development of the crop is good, it's vigorous. The yellow is, I'm gonna show you something better. The yellow is a bad development, okay? The crop is not growing well. And red areas are areas without any vegetation, like a path or a house, something like that, okay? So farmers can monitor their crops and they can see how it is developing, how it is evolving. And in the case that they see something like this, what does it mean? It means that something bad is happening here. So they can see this quickly and make a decision quickly as well and solve the problem, whatever the problem is, with irrigation, with a plague, with fungus, whatever it is, they can solve it quickly. So, like you can see, this is a very useful tool. The second source of information, like I said, is the sensors. Okay, so these sensors in this one is an stuck indeed. So this sensor is measuring soil humidity and temperature, air humidity and temperature, and solar radiation. Okay, so basically we have different graphs here, which are showing us all what we need. But maybe you think, oh, this is a bit complicated to understand. This is a bit difficult to understand. Let me show you how easy our app, FARMOO, transform these pretty difficult graphs in something as simple as this, for example. So there you have a few graphs, okay? These graphs are the graphs that the farmers see in their app, and it helps them in different ways, okay? First of all, we have, for example, watering forecasts. We can see the soil moisture content in the soil, and look at how simple this is. Basically, the farmer needs to control the red line, okay? The red line, the total amount of water that is in the ground, okay? This is the sum of all the profiles, all the depth. And they need to control that this red line is in the green area, okay? Because that's the field capacity. If the red line goes to the blue area, the crop is in danger because there is an excess of water, okay, an excess of humidity. If the red line goes to the red area, it means that the crop is in danger because of deficit of water, okay, and the crop could die. So it is so easy to understand and how easy to see what is happening in our crops, okay? Also, we can control, for example, how deep that water is, because it depends on the crop. We want the water deeper or not that deep, indeed. Look at that, so easy to understand. So basically, we need to maintain the lines in the field capacity between these two lines. This is so simple. Basically, what I'm trying to say is like this platform is designed for everybody to understand it, not just an engineer, but also farmer. I mean, nobody needs to have a degree to understand this. And that was our purpose. That's one of the reasons, because, for example, where we provide the amount of water, the volumetric content in the floor, in the soil, we provide it in millimeters. Because if we provide it in percentage, it could be difficult to understand for farmers. But we provide it in millimeters, because when they talk about how much water do my crops need, they talk in liters or millimeters, not in percentage, okay? So we do it easy. It is easy to understand, okay? We can see if our lands are okay, if there's a little bit of deficit. In this case, you can see that there is a little bit of deficit, just a 9%, but it's okay, it's not bad actually. And for example, we can also have an historical of watering data. All this information is really useful and simple, easy to understand, okay? Now, to continue, the third source of information is weather forecast, like I said before, okay? So the farmer can see what is going to be, how is the weather going to be in the next days, not just the weather, but different parameters that he wants to know about. And also something good from FARMOO is like farmers and agronomists, they can interact with this app. So basically, this is not an app where you get information, but you can't interact with it. No, you can choose so many different parameters. You can choose, for example, the weather station where you want to connect. In the case that you don't have an Agroop weather station, you can connect to the closest one, but maybe you don't want the closest one. You want one which is far because the conditions, the weather is more similar to your farm, and you can do it here, okay? So it's also good. And the fourth source of information is, like I said before, field records, okay? Farmers can have any observation they see in their lands or agronomists, they can have all that information in this platform, okay? So when FARMOO cross all that data, the information that farmers get is so useful. For example, I'm going to show you an example of how we cross data, okay, or how FARMOO cross data, and we provide useful information to the farmer. Here you have, for example, chilling and heat hours, okay, which is something that our sensors are actually measuring. But for example, and spray forecast, okay, depending on the weather forecast in the next few days, and depending on the conditions, okay, FARMOO gives a recommendation of what's the best time to spray if you need to spray something, whatever it is, fertilizer or whatever, okay? And this is an example of how difficult it would be to understand this graph and how FARMOO translated in something as simple as this. This graph is so easy to understand for any person, okay? For example, the green area is the area where it's the best time to apply to spray, okay? Yellow area is not the best time, and the red is not at all, okay? Because of the conditions are not the best. Look at this. For me, as an agronomist or as an engineer, this is difficult to understand. Imagine for a farmer. For me and for any person, this is so easy to understand. And it's the same, but this is the translation. This is what FARMOO does for all farmers and all agronomists. So basically, this is all. I hope you could understand a bit better who we are. And I hope you could understand a bit better how we work. And I hope, I would like, as a conclusion, I would like to say that agriculture in general and farming is facing plenty of challenges, so many challenges in the future. So there is so much work to do. There are plenty of jobs in this sector, okay? So I just hope that, I would like to encourage you to take part of this challenge, to all of you, students, professors, to take part of this challenge, because of this is a very promising sector. That's it. I hope you enjoy it, and thank you very much for the opportunity that you gave us to Agroop to be here with all of you.
Thank you very much, Antonio, for your presentation. It was really clear. And now it's time for questions. If someone has any question to
Of course, yeah.
Antonio? Yeah, there's one. This application that you showed, partly based on satellite information, is mostly suitable for open field crops. Do you also have options more adjusted to greenhouse crops or growers?
Say again, if you don't mind, Albert, just repeat the question, please.
Okay, yeah. This application that you show, the one partly based on satellite information, is mostly suitable for open field crops. Do you also have options more adjusted to greenhouse crops or growers?
Okay, so at the moment, the satellite tool is not available at the moment for greenhouses, okay, because of obvious reasons. We can't see through the plastic. So obviously for those crops which are in greenhouses, this option is not available. Anyway, I have to say that, how do we supply that? Because of our sensors are capacitive sensors. What does it mean? It's one of the most exact sensors in the market. So I'm sorry to say that no, for someone who has crops in greenhouses, they can't use the satellite. Sometimes what happens is like these sort of crops, which are in greenhouses, part of the year, they are not covered. So they can use the satellite that part of the year. But obviously, once they are covered, it's impossible, unless the farmer uncovers the crop, which is not very, obviously, it's not ideal. But anyway, how do we supply this? Obviously, they can't control that. I mean, they can't control the development of the crop by satellite, but the sensor is so accurate. So if they use all sensors, they will have a very realistic idea about the water needs that the plant has. Also, like I said before, we are working, we are innovating a lot. We don't stop innovating. So we are already thinking, working with drones, okay? So in the future, we would like to work with companies that uses drones. So it could be, maybe it could be, we could work with drones inside of a greenhouse, okay? So we can provide some part, like this information, not from the satellite, from the drone. I mean, we are already thinking about this because it's one question that is also very common, indeed. But at the moment, we can't offer a solution for greenhouses in this field.
Thank you. There's another question. You mentioned working with the small farmers.
Yeah.
How big should the farmer be, at least, in land capacity in order to profit from this technology?
Okay, I'm going to give you examples, and I could show you in FARMOO. Like I said, it depends on the crop. It doesn't depend on the sensor really. So if I mean, I'm going to give you examples. We have farmers which owns 2.5 hectares and of oranges, and they have a sensor, okay, and they're using a sensor. We have farmers that have sensors in half an hectare. Obviously, it depends on the crop. If they make money with that crop, obviously, it's affordable with them. I mean, this is about making money and saving money. We are not going to install so many sensors to lose money. So we need to be realistic, okay? If the crop that we've got is profitable, I mean, we can have one sensor in half an hectare. If that crop is not profitable, obviously, it doesn't worth it. But I'm going to give you an example. I have farmers with one sensor in half an hectare, and they have farmers with one sensor, and they control 145 hectares with just one sensor. So that's the reason, because I said this is available for everybody, small farmers and big farmers. It depends on the crop, really. If they make money with the crop and the crop is profitable, one sensor in half an hectare is enough, it's good. If the crop is not that profitable, obviously it doesn't worth it.
Cool. Thanks. And in here, Majed has sent 4 different questions. Well,
Good,
5,
good.
sorry.
I'm happy to know that people are interested, in this.
Yeah. The first one, how accurate are the maps, the spatial resolution, compatible with unmanned aerial vehicles, so UAVs?
10 square meters. Okay. Next year, at the moment, we're working with Sentinel-2. And this is the European Spatial Agency. And the maps are 10 square meters, okay, the precision. Next year, we are going to work with Planet, which is another company. And the images, the pictures are going to be 3 square meters, the accurate. It's going to be better. And also, we're going to have pictures every day, not just every week, because at the moment, the farmers get 1 picture every week, approximately. Okay, it depends on the climate, really, and the weather. Sorry, not the climate, the weather. But next year is going to be 1 every day and 3 meters of precision.
Okay. Second question is the software compatible with exporting data and reports with a standard extension? I suppose that Excel files or CSV.
Yes, as long as that data, I mean, that, let's say, imagine a company, no? If that company or that program works with APIs, what we call APIs, open information, it could be imported in FARMOO, okay? Anyway, obviously, we'd have to speak with this person in particular, or this company, to implement this information in FARMOO, okay? Because it's not that easy. And I'm going to give you an example. At the moment, we are working with different weather stations. But it's true that there are more weather stations in the field. one of our clients was complaining one time because of in the place where he owns the lands, the closest weather station in FARMOO was 67 kilometers away. And he was saying that there is one weather station really close to my farm, 5 kilometers away. And they was like, yeah, but the company which owns that weather station hasn't got APIs. So we can't, introduce that information in our system. So as long as these companies and this information is available with APIs, it would be able to import it in FARMOO.
Okay, another question. What is the accuracy of the weather forecast, and is the software compatible with the local stations in the field? Well, I think that more or less you have answered. The accuracy, I suppose that it depends on the sensors that are being used in the...
I mean, about the weather stations, all weather stations, they are obviously 100% accurate. In terms of other weather stations, they're accurate, but obviously they should be as close as possible to our place, to our farm, because of obvious reasons, because of rainfall is so as closer they are, as more accurate they will be, the measures and the measurings will be.
The fourth question, does the software analyze the input of sensors in the field and give a recommendation or prediction of what might happen based on the current conditions?
Yeah, that's what it does. I mean, basically the sensor is measuring different parameters. So let's say that the sensor measures the parameters and FARMOO translate that information and provides the graphs, okay? Really easy graphs.
And finally, what crops are compatible with the software?
Any crop. Any. I mean, we are working with so many different crops. I would say olive trees, vineyards, any vegetables, any tropicals. At the moment, because of the accuracy of the sensor is quite high, so it makes possible to be very accurate in terms of any crop. Also, all sensors, they measures different depths, like you could see. And we have different sensors that we have. One of them is, well, the Stuck, 60 centimeters. It measures 4 different depths. And we have another Stuck, which is 90 centimeters deep, and it measures 6 different depths. So it is good for any crop, like big trees or really small plants, like strawberries or, blueberries. It works really well.
Okay, and another question from Ruth says, Antonio, you mentioned that you may need a sensor per variety or per type of soil.
Yeah.
But what about the statistical power?
Well, at the moment we don't complain. I mean, we don't think about that because we didn't think that was necessary. Anyway, I didn't understand the question very well. So what does Ruth means with the statistic of power? About the crop or about the sensor?
Well, probably it's better if I talk instead of writing. I'm thinking about, I was hearing you and I was thinking about the statistical power of your measurements. Okay, because probably only one is not sufficient. I don't know, even because you talk that you are telling that one sensor could be sufficient per hectare. Yeah. It seems too high. I don't know.
I mean, Ruth, it depends on the soil and on the crop, really. So, for example, in terms of soil, you know that some places the soil is very homogeneous. So, for example, I'm going to give you an example. Here in Andalusia, where I live, where I am from, I'm in Cordoba. There is a huge area which is the soil is a vertisol. I don't know if you know about edaphology, and that area covers thousands of square meters. I mean, and it's so easy because big farms with, like I said, 140 hectares. I mean, it's so easy for them. It's the same soil everywhere. So with just one one sensor would be enough to measure all the crop, because of the soil is the same, the climate is the same, the variety and the crop is the same, olive trees, most of it. So farmers don't need any more. And that's really good because they can save so much money. Nevertheless, some other areas, for example, more mountainous areas, they're more complicated. So obviously we would need more sensors depending on the orography or the soil, because it changes more. Or also, I mean, before I was asked about greenhouses, we have sensors in greenhouses, but you know that the soil used in greenhouses, it's fake. It's coconut, or it's not real sand. Or well, maybe it's sand, but it's very, so because of those crops are very profitable, in half an hectare is enough. And because of these sensors are very accurate, it allows the farmers to have benefits with, I mean, one sensor. Spending 2,000 euros, they can manage half an hectare and make money and save money, obviously, especially because in these sort of crops, greenhouses, they water a lot. The irrigation, the amount of water they need is quite high. So that's the reason, because it's very profitable for them. And also because of they can implement this technology, because of they use a lot of water, so they can save so much water indeed. I don't know if I answered your question.
Yes, thank you.
You're welcome.
And finally, the last question, because we're a little bit out of time, but do you have customers in Africa? And if I'm not wrong, you mentioned that right now, yes.
We do, yeah. At the moment, we are working in Morocco, okay, and we are opening market as well in other countries. So yeah, I mean, we're working in Morocco with through a partner, really, but they are using our sensors, and we are also going to open market soon, if everything goes okay, in Asia, Azerbaijan or Uzbekistan, etc. I mean, as long as they have connection, like it works anywhere, really.
Okay, so again, thank you very much, Antonio, for your presentation.
Thank you to all of you. Thank you.
And thank you for joining us in our workshop. So as expected, now we have not 30 minutes, it will be only 15 minutes of break, and see you in 15 minutes to continue with this interesting session. So see you in a while.